Welcome to Physics World. Every day in the morning, if you observe different things around you, for example, a boy throwing a ball in upward direction, then what you observe? Do you observe that the ball is keep on moving in the upward direction for a long time, or within seconds it's falling on the ground? And if it is falling on the ground, why it is so? A person jumps from a certain height, then the person doesn't float in the air. He or she has to fall on the ground. Why? A rocket motion. Rocket always moves in the upward direction. Scientists say that the rocket should have a fixed minimum velocity, then only it can move in the upward direction. And they have estimated that it is escape velocity and it is 11.2 kilometers per second. Now the question is why the rocket should have 11.2 kilometers per second to move in the upward direction. In the solar system, take example of planet, our planet Earth. Earth is rotating around the sun. Why the Earth has to rotate around the sun? Why can't it can come from this orbit or from its path and move in some different direction? Why it is happening like this? An aeroplane, when it is moving in the air, the bag is falling. When the bag is falling, the bag doesn't stop in the air. It's keep on gradually falling to the ground. Why it is? So these are many questions in our mind. And for all these questions, there is only one answer you can expect. And that the answer is gravitation. So today our chapter is gravitation, and we discuss about what is gravitation, what is gravitational force, and what is the role of Isaac Newton in this chapter. And gradually we move on to different concepts in this chapter. Before the discussion of gravitation, we should know that why the objects or how the objects are moving in the circular path. Now see on the board, you can see different diagrams. In all these diagrams, only one thing is common, and that is circular path. Earth rotating around the sun in the circular path. Satellite rotating around the earth in a circular path. An electron rotating around the nucleus in the atom. A person whirling the stone tied to a string in a circular path. A car taking a circular turn in circular path. So all these circular paths, the question is how they are able to travel in the circular path. If you recall the mathematics of circles, take this example. If I ask a question that what is the direction of motion of earth at this point? Direction of motion of the earth at this point, I have asked you. Now what is your answer? Think about the properties of circles. Yes, you need to draw a tangent at that point, and that tangent gives the direction of the motion of the body. That tangent also gives the direction of velocity. So I can say the earth is moving in this direction, tangential direction. For example, if you ask me here, so this is point A, this is point B. At point B, what is the direction of velocity or the motion of the body? Simple. You draw a tangent from that point. It gives the direction of motion or the velocity. If you ask what is the direction of the body at point C, same method you follow, same idea. Draw a tangent, v is the velocity. So at each and every point on this path, if you want to know the direction, you need to draw the tangent. If you see all the tangents, these tangents are changing their directions, and make sure that the body is in the circular path. But the question is how? How this earth or the body still continue to be in the circular path? It is because some force is acting on this body, and that force is actually by this body, relatively massive body, sun. The sun is applying force on the earth, And because of that force, Earth is not leaving the path. It is in the circular path. And you know what is that force called? Yes, that force is called centripetal force. Centripetal force. Say the symbol is Fc. Centripetal force is the force acting in the circular paths, and always it is towards the center of the circle. For Earth circle, the center is Sun only. So that's why the centripetal force acting towards the center, that is Sun. So this centripetal force makes sure that the Earth should be pulled towards the Sun at each and every point. Now, at point A, if the centripetal force is not applicable, is not applied, then what happens? There is the answer on the diagram. When the Fc is not applied, immediate Earth doesn't move in the circular path. It moves in the tangential path. So it moves in this tangential path and away from the Sun. That's it. It doesn't come back to the Sun. Suppose at point B, if tangential force, at point B, if centripetal force is not there, what happens? Same. The Earth goes in a tangential path and never comes back. But it is coming back in the circular path because this centripetal force pulling at each and every point on the circle to make sure that the Earth in the circular path. And this is applicable for all these examples. The satellite is in the circular path because of the centripetal force by the Earth. The electron is in the circular path because of centripetal force by the nucleus. The string tied to a stone describing circular path because of centripetal force, Fc. The car taking a circular turn on the road because of the centripetal force. Okay, now understand what is centripetal force. So it is the force in the circular motion and acts always towards the center. Now one more important thing. Centripetal force, yes, I have shown the diagram, but actual centripetal force originally is not existing. Some force is acting like centripetal force. What is this? Yes. In all these examples, I am going to show you some different force which is acting like centripetal force. Coming to the first example, Earth is revolving around the Sun. Here, the centripetal force is actually not original centripetal force. Here, the gravitational force by the Sun or the attraction force by the Sun is acting like centripetal force. If I write gravitational force is Fg, now here Fg equals to Fc. So the gravitational force by the Sun is acting like centripetal force. Here, the gravitational force of the Earth acting like centripetal force. There, just recall your knowledge in atomic models. If you recall, you know that electron is having negative charge, nucleus is having positive charge. When the charges are unlike, there is an attraction force between them which is called Coulomb force. It is also called electric force. So here, the Coulomb force or electric force, Fe is called electric force, is acting like centripetal force. Now coming to here, the string is whirling around in a horizontal circle. It's because of centripetal force, but here the actual force is tension, T, tension in the strings. So this tension is acting like centripetal force. Now coming to the last example, when the car is taking a circular turn, you know that when you are driving the car on the highway with a very high speed, sometimes with the high speed, if you turn the cars, you can see in the movies, the car accidentally move away from the track and hits the other side of the road and meet the accident. So that's why what we do, the driver has to be very experienced at the high speed, has to take a safe turn. When he takes a safe turn, in that situation, the car doesn't move away from the track. It's only because of the centripetal force. It's pulling the car towards the center. And here the centripetal force is the frictional force between the tires of the car and the road. So if you see, in all examples, we have centripetal force, but different forces are acting like centripetal forces. Now, our context is this one, gravitational force. Gravitational force is acting like a centripetal force to make all the planets to revolve around the sun. Gravitational force of the earth is responsible for make all the satellites to revolve around it, to rotate around the earth.